Quantum worlds and parallel universes. Hugh Everett's groundbreaking theory. What if every decision you make doesn't just shape your future in this reality, but creates an entirely new universe? A new version of you, living a different path? This idea isn't science fiction. It's a theory that has redefined the very fabric of our existence. Welcome to the fascinating world of quantum mechanics and parallel universes, as proposed by physicist Hugh Everett. Hugh Everett's Many Worlds. Interpretation, a game changer in physics. 1957, a young physicist named Hugh Everett proposed a radical theory that would challenge the fundamental principles of reality itself. His theory, the many worlds interpretation, suggested that every choice we make creates a new universe. A universe where another version of us lives out a different reality, making different decisions and experiencing alternate outcomes. At the time, quantum mechanics was already causing a stir in the scientific world, with strange and mind-boggling ideas, such as particles being in multiple places at once. However, there was a significant issue at the heart of quantum mechanics, the observer effect. This theory suggests that the mere act of observing something causes it to take a specific state, which made it impossible to predict outcomes without interference. The scientific community was deeply divided between two schools of thought: the Copenhagen interpretation, which insisted that reality only existed when observed, and Everett's many worlds interpretation, which proposed a much wilder idea. Instead of the universe collapsing into one reality when we observe it, Everett argued that every possible outcome of a quantum event actually happens, but in different parallel universes. According to Everett, at every moment, the universe splits into multiple versions of itself. Every decision or action creates a branching reality, where each possibility is realized in a parallel world. Imagine your life as a tree, with countless branches extending in different directions, each representing a different version of you in a different universe. Why wasn't Everett celebrated? Despite the profound implications of Everett's theory, it was met with skepticism and indifference from the scientific community. At the time, the world of physics was deeply entrenched in the Copenhagen interpretation of quantum mechanics, which favored a more traditional and observable approach. Everett's theory was considered too speculative and lacked the experimental evidence to back it up. In fact, many saw his idea as impractical for real-world application. It wasn't until decades later, in the 1980s and beyond, that Everett's work began to gain the recognition it deserved. As technology advanced and our understanding of quantum mechanics deepened, more and more scientists began to see the validity in his theory. Today, many worlds is one of the most accepted and influential ideas in theoretical physics. The Mandela effect: parallel universes in action? The idea of parallel universes takes on even more intrigue when we explore a strange phenomenon called the Mandela effect. This term, coined by Fiona Broome in 2009, refers to the experience of large groups of people remembering an event or fact differently than it actually occurred. The term was inspired by Broome's own vivid memory of Nelson Mandela's death in the 1980s, an event that never actually happened. Could this phenomenon be connected to Everett's theory of parallel universes? Some suggest that the Mandela effect might be the result of overlapping or shifting realities. If parallel worlds exist, memories from one reality could bleed over into another, causing a collective misremembering of events. Cynthia Sue Larson, a well-known author and researcher, has spent years studying the Mandela effect and its potential links to parallel universes. She explores the idea that the Mandela effect might not be the result of faulty memories, but rather a glimpse into alternate realities where different histories unfolded. A personal Mandela effect experience. I personally experienced a shift in memory that seemed to parallel the Mandela effect. As a child growing up outside of North America, Thanksgiving was not celebrated at all where I was born. However, my mother always made a special lunch for me on the third Thursday of November in order to mark the day. We didn't observe Thanksgiving traditions where I was, but this date became an important occasion for us. When I moved to Canada, I didn't pay much attention to the exact date of Thanksgiving in the US, since the Canadian Thanksgiving takes place in October, not November. I thought little of it until I started noticing something unusual in Canadian stores. Every year, around the end of November, Canadian retailers began implementing Black Friday sales, hoping to attract shoppers and prevent them from crossing the border to the US for better deals. It was then that I realized Thanksgiving in the US was actually celebrated on the fourth Thursday of November, not the third, as I had originally remembered. I began to wonder, Why did I have such a vivid memory of Thanksgiving falling on the third Thursday? This memory didn't match the official date of U.S. Thanksgiving, yet it felt incredibly real. As I delved into historical records, I discovered that Thanksgiving in the U.S. was, indeed, celebrated on the third Thursday of November, for a brief period during the presidency of Franklin D. Roosevelt. In 1939, Roosevelt moved Thanksgiving to the third Thursday, but due to public dissatisfaction, this change was reversed. In 1941, Congress passed a law setting Thanksgiving permanently on the fourth Thursday of November, where it has remained ever since. This shift in my memory raised a thought-provoking question. Could this be a personal example of the Mandela effect at play? Is it possible that my memory of Thanksgiving falling on the third Thursday comes from a parallel universe? One where Thanksgiving stayed on the third Thursday for longer than it did in our world? The science behind parallel universes. Everett's work inspired many prominent physicists, including David Deutsch, a physicist at the University of Oxford, who has advocated for the many worlds theory in the context of quantum computing. Bryce DeWitt, another physicist, was also instrumental in the development of Everett's ideas, helping to popularize many worlds throughout the later 20th century. These ideas have not only influenced theoretical physics, but have practical applications in fields like quantum computing, where the notion of multiple realities could help develop new computational methods and algorithms. Practical applications, expanding consciousness. So, how does Everett's theory of parallel universes relate to our everyday lives? Could our understanding of parallel worlds help us expand our consciousness? By acknowledging that all versions of ourselves are playing out in parallel realities, we might begin to realize the profound power we have over our present moment. Every decision we make can open up new worlds of possibilities. Perhaps our consciousness isn't bound to just one path, but is interconnected across many dimensions, offering us infinite opportunities to explore and grow. Everett's many worlds theory challenges our understanding of self, fate, and free will. It invites us to consider that our choices matter not just in this reality, but across countless parallel universes. This awareness could inspire us to make more thoughtful decisions in our lives, knowing that each choice could lead to a new reality, a new version of ourselves, living out a different story. Hugh Everett's groundbreaking theory of parallel universes has reshaped the landscape of physics and has profound implications for how we view the nature of reality. As we continue to explore quantum mechanics, we may just unlock the mysteries of the universe and discover new ways to connect with the vast multiverse that surrounds us. Could the idea of parallel worlds change the way we live, think, and grow? The possibilities are endless. Let's keep exploring these infinite possibilities together. What do you think? Could the many worlds interpretation hold the key to understanding the true nature of our reality? Thanks for watching.